Before we discuss the final two methods or tools that we can use for capital analysis and capital investment budgeting, let's take a look at the time value of money and how we compute the present values from lump sums and annuities. So when we're talking about the time value of money, obviously a dollar received today is worth more than a dollar to be received in the future. And this is not rocket science. It's simply the fact that if I have cash today, I should be able to invest that cash, whether it's in savings, whether it's in inventory for resale, property, plant, and equipment to manufacture my product. So a dollar today can be invested to generate a return sooner than a dollar tomorrow. And so the fact that we can invest this cash and it's going to generate some type of interest or return is called the time value of money. So when we're looking at the time value of money, we've got two different capital investment analysis that we will consider, the net present value method and the internal rate of return. But we have to understand the present value tables in order and calculations in order to utilize these two tools. So the time value of money depends on three primary factors. What is your principal amount? And are you investing a single amount, or are you invest as a lump sum, or are you investing a series of amounts over a period of time, which we will call an annuity? We also have to know how long. If I invest cash today for 5 years, or I invest a series of payments over 5 years, that would be different than an investment over 10 years. So we need to know the amount of time that the investment is going to be tied up until its termination, and then we need to know the interest rate. So the interest rate is the annual percentage rate on a particular investment that will be calculated over time and over the amount of principal or series of annuity payments that have been invested. Now, there are two different kinds of interest that you should have heard of by now. The first is simple interest, which simply means that interest is only being calculated on the principal amount that is in my particular account. So if I invest $10,000, I will generate interest on, simple interest means I will generate interest on that $10,000 every year, but only on the $10,000. Compound interest, on the other hand, says that interest is going to be calculated not only on the $10,000 amount or principal that I have invested, but all of my previously earned interest. Let's take a look at an example. If we have simple interest, I've invested $10,000. This is our P for principal at 6%. This is our I for interest, and for 5 years, this is our N for time. So if I have $10,000, if I just have a simple interest calculation, so we see here, then it is simply $10,000 times 6%. I will generate interest of $600 a year, and if I do that for 5 years, that's $3,000 worth of interest. Now, on the other hand, compound interest is what we would rather have, and so the first year is the same. I have a $10,000 investment with 6% interest. I have $6,000 worth of interest income at the end of the period. However, with compound interest, in the next year, I'm going to gain interest not only on this $10,000, but on the $10,000 plus the $6,000 of interest that I earned the prior year, generating $636 worth of interest. So the next year, I'm going to get interest on my $10,000, the $600 from interest the first year, $636 from the second year. So you can see the interest begins to build. Obviously, compound interest is going to generate a little more interest than just our simple interest rate. Okay, we'll have to take this into consideration when we're looking at our present value factors, right? So the present value factors, a couple of different things in mind. You'll notice it says the future value of an investment in our example is simply its worth at the end of a 5-year term. Well, the present value is whatever I have today, okay? But if I want to know the future value, it is simply that $10,000 that I invested today plus the interest earned will show me what the future value of a particular investment will be. So the future value is simply the principal plus any interest that we have earned. So the text is provided, this illustration from the table for you. If I want to know the future value, how much money will I have in the future if I invest $10,000 today for 5 years at 6% interest? I can calculate the future value simply by taking my principal plus my interest is $13,383. We can rearrange this equation, as your book has said. We can calculate the present value. If I know the future value and the interest that it would have earned, I know how much. So I can also work backwards to determine how much do I need to invest today to have $13,383 in the future at 6% in 5 years. Okay, so we can obviously do this with a financial calculator. The table that we have here is very nice, but it can be very tedious. But this is a very simple formula. If we put it into an Excel format, you have a business financial calculator that will do this for you. There are calculators online that will do this for you. It's a very simple calculation. But we're also going to utilize present value tables, and we have those in your appendix, and which will do the very same thing for us as the calculation that we could do in Excel or in this table. So we will start by addressing, the present value of a dollar table. So this is a present value, basically, of a lump sum. It's in Appendix B, and it's Table B1. And so what we would use this for today, use to calculate the value today of one future amount. So if I want to know how much I need to invest today, a one-time investment to have $20,000 in the future, a lump sum, I can use the present value table to do that. If we want to know the present value of an ordinary, we can also use the present value of an ordinary annuity table. What if I want to know the value today of a series of equal payments? So how much do I need if I have a series of $5,000 of payments for the next 5 years at 6% interest, then what is the value of that investment today? In this situation, we would use the present value of an ordinary annuity at $1. So once again, this table is in your appendix. We'll put this into actually an example for you. If you want to know how much you would need to invest today to have the $13,383 in the future, and we know that we've got 5 years and our interest rate is 6%, we go to the present value table in Appendix B. You can go there if you would like. It's Table B1, and I want to know the present value, and I'm basing that on the future value of $13,383. If I scan across the table for 6% for 5 years, I will find the present value factor is 0.747. The present value factor, using scanning across that table, rows and columns, 6% for 5 years is 0.747. 0.747 times $13,383 means I would need to invest $9,997 today to have $13,383 in the future. So with rounding, this would be the $10,000 that we have seen in the prior examples. But what about an annuity? So assume that instead of receiving a lump sum at the end of 5 years, I want to know the present value of receiving $2,000 at the end of every year for 5 years. So in this case, I want to go to the annuity table for a present value. And this is, you can find this once again in your appendix. We know the amount of cash inflows each year, $2,000. So I go to the annuity present value factor table, and we know that it's 6% in 5 years. My factor is 4.212. So when I multiply that times the amount of cash that I would be receiving each year, the present value of that series of or stream of payments would be $8,424. So if we put this into a real life situation, we've just seen one of the largest Powerball lottery winnings probably in history. And so if you're familiar with how the lottery operates, you can receive a lump sum payment, or you can receive an annuity, a series of payment over time. So our text says, let's take a look at this. What if you could receive $1 million today? What is the present value of $1 million today? $1 million. It is, the present value is what it is. But what about option 2? What if the lottery said, or I can pay you $150,000 a year at the end of each year for 10 years? Okay, so that's actually $1.5 million. So if you will let us spread those payments out over 10 years, I could pay you $1.5 million instead of $1 million. Or if you will wait for 10 years and just take a lump sum, I'll pay you $2 million. Well, if I'm looking at these without any additional analysis, I mean, 2 million compared to 1 million, why not wait 10 years? But what we have here is not a good comparison because I have a single amount today, the 1 million. I have a series of payments, $150,000 for 10 years, or I have a lump sum at 10 years. So the 1 million compared to the 1.5 million compared to 2 million here is not a good analysis. I am not comparing apples to apples and oranges to oranges. But the way that I can do that is to bring all of these numbers to their present value. So let's do that. So if I were to calculate the present value in the examples that we had just seen, of 1 million. 1 million today is 1 million, but on option 2, we would look at the annuity table, $150,000 a year. We would go to the present value of an annuity, and we would look at 10 years and 8% and multiply the 150,000 times what comes from the annuity table at 8% in 10 years, and I would get $1,006,500. If I bring the final option, just a lump sum at 10 years, the present value of a lump sum at 10 years and 8%, I would have $926,000. So if I bring all of them to their present value, now the most valuable option for me might be to take the $150,000 over 10 years, because that's the same thing as the present value of $1,006,500. And so when we bring them all together, they look a little different, and we have a better platform to make our analysis. So quantitatively, option 2 is our answer. I've never participated in a lottery, but and I'm pretty sure my accountant never has either, but she would tell you that you may not have tomorrow, so go ahead and take option 1, get your 1 million today, and we'll figure out what to do with it in the future. Those are those qualitative issues that you would need to consider. But here's the way that we quantitatively use those present value tables to bring everything to the same platform so that we can make a legitimate analysis. So now that we have some understanding of those tables underneath our belt and present value in general, take a break, look at those tables, see if you can do some calculations there, and we'll come back and look at the final 2 options that we have to use as tools when we're making capital investment decisions.